Hello, everyone. In this video, I will go to introduce you the solution for LeetCode weekly contest 348 for problems with difficulties 3356. And now go to the first problem is we are given a zero-indexed string s. Repeatedly, we can perform the following operation any numbers of times to choose an index I. And C will be the character in position I. Delete the closest occurrence of C to the left of I, if any, and the closest occurrence of C right of I, if any. And our task is to minimize the length of string by performing the above operation any number of times. So this is an easy problem like for each characters. No matter how many characters present there, because we can delete any possible present of the characters from left and right. So for each character, there's only one left. This is a code that we have this vector to calculate how many characters present in a string. And if this number is equal with 0, then we just continue. Otherwise, we may add 1 to the final answer. And now we go to the second problem. We are given an zero-indexed permutation of an integer's nums, and permutation is called semi-ordered. 1 is the first number, and n is the last number. And we can perform the following operation as many times as we want until we make nums a semi-ordered permutation. So we can select two adjacent elements in nums and swap them. Return the minimum number of operations to make nums and semi-ordered permutation. For this problem, this key observation is we need to find the position of 1 and the position of 1. And for position of 1, you need to switch an element above it. And for element n, you need to switch with the element below it. And there's one special case like 1 is after n. In this case, that when we calculate the switch numbers for 1 and for n individually, actually there is one swap is calculated twice. So we just minus 1 from the final result. This is the solution that we calculate position 1 and position n. And then we go to calculate how many swaps we need to do for 1, how many swaps we need to do for n. And then if P1 is bigger than Pn, we just minus 1 from answer. Now we go to the third problem. The third problem is like we have we are given integer n and 0 indexed to the array named queries, where queries first element is type I, second index I, and third value I. And initially there is a 0 indexed n by n matrix filled with n's. For each query, we must apply one of following changes. If type I equals 0, set the values in the row with index I to be value I, overwriting any previous values. If type I equal 1, set the values in the column with index I to value I, overwriting any previous values. Return the sum of integers in the matrix after all queries are applied. So when we query the scale n, actually this is big, so blue files doesn't work. Root files doesn't work. So what we should do is, this one key operation is, we should do this from end to the beginning, not from beginning to the end. Reason is, for example, if for this one, the first example, when we apply the last operation, this column's value will be overwritten 4. So no matter what other operations about this, after this column is 4. So sum of this column is just 4 by 3, and this can be calculated, right? And now we go to the second last operation. We overwrite this row to this 3, and we can see all of the cells on this row are overwritten except for the first one. The first one is because we have some operation after this operation to overwrite this cell. So we just need to calculate how many cells this row will be overwritten by the operations after it, and then we can get how much is the values this operation can contribute to the final result. The same like when we override any columns or any rows, it's just the similar logic. Now we go to the codes. Right? We have vector, boolean, column, and row. So this is just a record which column or which row is already overwritten, and this variable user row means how many rows are overwritten, and use the column just means how many columns are overwritten. And this is the final answer. So we iterate from the last queries to the first one, and for each query we go to check whether its type is 0 or type is 1. If it is 0, then we get the row will be overwritten and the value we use to overwritten, and then we check whether this row is already overwritten. If it is, we continue, we do nothing. Otherwise, we may go to record this row as overwritten, and we calculate how many cells on this row can be overwritten with the new value, and add them to the final answer. And then we also use the row by 1. The same logic will be applied to column. Okay, so this is the third problem. Now we go to the fourth one. The first one, we are given two numeric strings, num1 and num2, and two integers, max sum and min sum. We denote an integer x to be good if it's between num1 and num2 included, and its digit sum is between min sum and max sum included. Digit sum just means it's a sum of all the digits of x, right? And then we return the number of good integers. Since the answer may be large, return its model 10 power 9 plus 7. Okay, so for this problem, when we check the scale of the number, it can be very big, right? So for this one, we need to use dynamic programming to resolve this problem. Let me try to explain idea before this. So we go to check, for example, like we have the number 0, 1, 2, and go to 9. Then for this column, this is the digit sum of the number, right? For these 10 numbers, its digit sum just equal its value. So it's just like 0, 1, 2, and then go to 9. Okay, so now how about when we add 1? 10th position, so it will be 10 to 19. And what is their digit sum? So it's just like 1 to 10. So it's just like all of this digit sum of the first 10 numbers plus 1. That's because we add 1, right? We add 1 at the 10th position. And the same logic that we can calculate like 20 to 29. Until we can use this logic to calculate to 99. These are all the numbers with 2 digits. And we can use this. We can use the first 10th digit sum to calculate all of the digit sum of the numbers with 2 digits. And similarly, we can make use of this result to calculate numbers with 3 digits. It's like 100, 101, until go to 999. So such like for this one, right? So if we don't calculate digits, highest position, it's just like 0, 0. It's just like 0, 1 until 299, right? It's just the repeat of this. So this is how we do dynamic programming to calculate. We need to calculate array like this. So this array may have two. It may have two elements. First element is called digit count. The second element is the digit sum. And this value would be how many numbers. So generally this means how many numbers will have this digits count and its digit sum equals with this value. So this just make the idea here to calculate this array. And then we have this array, right? So for this problem is let us to calculate actually the good number between num1 and num2. And what we can do is we need a method. So we need a method. This method will have a number. It will have a number as the input, and the result would be how many good numbers. How many good numbers? From 0 to num. The input variable. Sorry, to the input parameter. And when we have this function, right? So we calculate the result like make f to the like num sorry, it's like num2 minus f num1 minus 1, right? So this will be our answer. And to calculate this answer, and we need to implement this function, right? So let's think about when we have this array, how we implement this function. Right. So I may use some use here to explain this. So let's think about a tail example. For example, I want to calculate function 2, 3, 4. And for this function, the input parameter is 2, 3, 4. And then we check from the highest position to the lowest position. And the highest position is 2, right? So that means for digits 0 and 1 at the highest position, right? It has the number from, for 0, it has the number from 0 to 99. And for 1, it can also has the number from 0 to 99 at the lower position. So in this, for this range, we can make use of this array to get how many numbers and how many numbers we have for so this is like P2, right? Because here we have 2 digits at the lower position. There are 2 digits, and for here for the digit sum, it would be we need to consider from 0 to 400. This is because that we say the mean sum and the max sum is from 0 to 100, right? So that means we just need to consider the sum between this range. So here we need to consider the sum from 0 to 400. And for each of these, we know how many numbers in this range, right? So we just add this to another array. So let's array just like, so for example, we call this like a result array. We need this array to be 400. Actually, it's need the length should be 100 and 401. So we just add this number to this array. But this is about we consider digits 0 and 1 at the highest position, and how many numbers we can get with the digit sum from 0 to 400, and we calculate them in this result array. And now we know that the first digit can be 2 now. For this one, so we just need to record another thing like pre. Pre means prefix digit number sum. So now the prefix digit sum like 2, because now the position is 2, right? And then for this position, we need to consider the digits from 0, 1, 2. And for each of the digits, lowest position is just one position. So it's like for each this position, we need to consider from 0 to 9, and 1 also from 0 to 9, and 2 also from 0 to 9. Similarly, we can use this dp. So it's just like dp 1 and 0 to 400. And we need to calculate the pre and also the current digits, and then at the current digit sum in this array, and then add them into this result array. And similarly, so now we need to consider a higher position are fixed to be 2, 3 now. And now we consider the lowest position is 4. So we need to consider it from 0, from 1, from 2, from 3. Okay, now because we don't have any other lower position, it's just like we calculate this number. And if its digit sum is in the range, we just update the result sum. And also we need to consider 231, 232, 233, and 234. Just use the result to update the result array. And finally, that we need to just calculate digit sum between min sum and max sum. So we use this result and just calculate the digit sum between mean and max to calculate how many numbers we have in this result array. That is the final answer. And we can go to check the codes. So this is just use a reference, because actually my code is not clean enough, but this can be a reference that you can implement your own code to resolve this problem. Let's say first of all, I define a nums. So actually this nums is the DP array. Okay, and for the first 10 digits, I just update that there is only one number that with digit count is 1, and this is the digit sum. It's equal with its value, right? So it's just 0 to 9, and there is just one number in each bucket. And now I iterate from this is iterate the digit count from 2 to 21, and for each digit count, I go to iterate a number from 0 to 9, and for each of this number, I go to iterate so k from 0 to 400. Actually, this is the digit sum that for each of the digit sum of the digit count that is lower than the current digit count, right? So use this to add it into the current digit count result. Here the logic is go to implement the -1 from num1. So as we explained here, that we use this function to calculate result, and we need the minus num1 by 1. And here we implement this num function. Num function, it's just like so this is the prey, and this is the digits. So that means the current positions digits, and this is the size. That means how many digits at the lower position, and if digits lower, or if lower position is 0, in that case we just calculate prey plus current digits, and if it's in the range, then I just use this result to update this answer array. Otherwise, I iterate each of the digits count, and I calculate whether the prey plus current digits as this digit count, whether it's still in the range. It is in the range, and I use a dynamic array result to update this answer array. And this is go to update prefix, and this one is go to calculate the last term. So this is actually the exact numbers. Actually, here is the value. The value is digit counts. If it's in the range, I also need update answer with this result. And here I just calculate between the min sum, min num, and max num. I added all of the value in the answer vector into the final answer and return final answer. And now I use value 2 minus value 1 will be final answer. Okay, so this is all of the resolution for this week's LeetCode contest. Please let me know if you have any questions or comments. Thank you.